Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to discuss about the concept of hashing and types of hashing in database management system. So hashing and types of hashing. So before going to explain that hashing, so what is meant by a bucket and what is meant by file organization. So a bucket is a storage place. A bucket is a unit of storage which containing one or more records. One or more records. So hashing is nothing but the different types of records has to be stored on based on the method of hash methods. Based on method of hash methods. So hashing is an indexing mechanism. Hashing is an indexing mechanism which used to find the records, with the help of hash functions, So for that we are creating a buckets. And we are going to organize the different files also. We are going to create buckets and we are going to organize the different files also. So we said what hashing is. Hashing is an indexing mechanism or searching mechanism. To retrieve the data. Searching mechanism to retrieve the data on basis of hash functions. So hash function, applying hash function to find the records based on the indexing keys or indexing mechanism. For that, what we need to create? We need to create bucket. As well as file organization. So here, a bucket is unit of storage containing one or more records. A bucket is typically a disk block. In a hash file organization, we obtain the bucket of record directly from its search key value using hash function. So in a hash file organization, we obtain the bucket. So bucket is nothing but what? A unit of storage it contains. So in a hash file organization, we obtain the bucket of record directly from its search key value. Based on the search key values, we are going to obtain the buckets using what? Using the method or function hash function. So hash function indicates with the H symbol. So hash function H is a function from the set of all search key values K to the set of all bucket addresses B. So which contains what? All the search key values K and the search key bucket addresses B. So it contains address of the next records as well as search keys. So hash function is a function from the set of all search key values and the set of all bucket addresses So hash function is used to locate records for accessing. So this function is used to locate records. So to inserting records, to updating the records, to retrieve the records for access or insertion as well as deletion. So as the indexes, primary indexes, secondary indexes, how they are useful to retrieve the records or insert the records or delete the records. In the same way, this hashing method also work out. So records with the different search key values, may be mapped to the same bucket. So each and every values are mapped to the bucket. With the bucket. Thus, entire bucket has to be searched sequentially. To locate a record. So what it indicates that what? Records with the different search key values may be mapped to the same bucket. Thus, entire bucket has to be searched sequentially to locate the record or to retrieve the record. So if bucket doesn't have any search key values, then it takes a lot of time to access the particular record. So example of hash file organization. So hash file organization of instructor file using department name as key. Using department name as key. So there are 10 buckets. If I take an example, there are 10 buckets. The binary representation of the ith character. The binary representation of ith character is assumed to be the integer I. Assumed to be the integer I. The hash function returns the sum of the binary representations of the characters modulo 10. The hash function returns the sum of the binary representation of the character modulo 10. Of the characters modulo 10. So here, suppose hash function of music is 1, hash function of physics equal to 3, hash function of history equals to 2, and hash function of electrical engineering 3. So these are all the records that are in the instructor department names. That are all in the instructor department name. So here the example indicates that hash file organization. So if take a bucket, buckets are storing for all the values. If take a bucket 0, it doesn't have any values. It doesn't have any values. But bucket 1 having one value, which having 15151. And bucket 2 is also having two values. Bucket 2 also having two values. And bucket 3 also having three values. Bucket 4 also having two values. Bucket 5 also having one value. Bucket 6 also having three values. But compare all these buckets are having the search keys or not, or else is the same records to be founded in the another bucket or not. So as we said in the previous, the bucket are stored for each and every search key values that are pointed to the records. So here hash file organization of instructor file using department name as key. So here the search key is what? Instructor department name as a search key. Department name as a search key. For that it indicates that what? H of music. That means the music department name is located at where? Department name music is located what? Is located at bucket 1. Similarly, the history of the record are located at what? Bucket 2. So history is located at bucket 2. And similarly, physics is located at bucket 3. Physics is located at bucket 3. And electrical engineering is located at also bucket 3. So now, by using this hash function with the help of search keys, it finds the records is to be very easily, and also the access time is also less to find out the records is to be very easy. Suppose if you want to find out the record H of computer science, then it shows that what? Bucket 6. It shows that what? Bucket 6. So creating organization of the files in buckets is very easy than that index filing mechanism. So that each and every bucket is separated as indexes are created. So separate buckets are storing that all the values, and separate buckets are accessing the data is very fast. So hash functions. There are different types of there. So worst hash functions maps all search key values to the same bucket. So if all search key values in the table is going to be have in the same bucket, then it shows that what? It is a worst hash function. So the access is time proportional to the number of search key values in the file. So the access time is directly proportional to the number of search key values in the file. If more number of search keys are there, then the access time is also takes lot of amount of time. An ideal hash function is uniform. That is, each bucket is assigned the same number of search key values from the set of all possible values. So each bucket is assigned the same number of search key values from the set of all possible values. If ideal has function as random, so if it is uniform is nothing but what a bucket is assigned with the same number of search key values from the set of all possible values. So bucket assigned with the same number of search keys. But here the random indicates that what each bucket will have the same number of records assigned to it irrespective of the actual distribution of search key values in the file. So distribution of search key values are different, then the records also having the difference. Suppose from this diagram we can observe that the bucket having the one value, bucket having two values, bucket having three values. At this moment, the same number of records are available, same number of search key values are available. So bucket one having one search key, bucket two having two search keys, or else one search key. The same number of search key values are assigned with the each and every bucket. So that a function is uniform. That function is uniform when if each bucket is assigned the same number of search key values. If the bucket will have the same number of records with irrespective of actual distribution of search key values in the file. So typical hash functions perform computation on the internal binary representation of the search key. So for example, for a string search key, the binary representation of all the characters in the string could be added and the sum modulo the number of buckets could be returned. So that means the number of buckets having the same number of search key along with the records, or else the number of search keys are different number than the records are available in the bucket. So how the bucket overflow will occur at the moment of the more number of records are instructed in the bucket. So suppose bucket one is limited for 3 records actually. But if you want to insert more number of records like a 4th record or 5th record, then the bucket will becomes an overflow. So it occurs because of insufficient buckets. So if the more number of buckets are created, then there is no insufficiency occurs. But if bucket overflow can occur because of insufficient buckets, so skew in distribution of records, this can occur due to two reasons. One is multiple records have the same search key value. So for all the buckets, the search key value is to be same. That moment bucket overflow will occur because for all the buckets the same search key is distributed means it takes a lot of time. So multiple records have same search key values leads to the bucket overflow. And the chosen hash function produces non-uniform distribution of key values. So chosen hash function produces non-uniform distribution of key values. Although the probability of bucket overflow can be reduced, it cannot be eliminated. And it is handled by using overflow buckets. So if insufficient buckets are there, then bucket overflow will occur. But the skewing distribution of the records will be occur based on the multiple records have the same search key values, or else chosen hash function produces non-uniform distribution of the keys. So here you can see the diagrams. You can create the bucket 0, bucket 1, bucket 2, bucket 3. But here the bucket does not having, that is nothing but more number of records are inserted. Then the bucket 1 will leads to overflow buckets for these two are the overflow buckets for bucket 1. overflow buckets for bucket 1. So here overflow chaining is the process. The overflow buckets of a given bucket are chained together in a linked list. It follows the linked list manner. The overflow chaining occurs. The overflow chaining happens in the linked list manner. So above this scheme is called closed hashing. Above this scheme is called what? Closed hashing. An alternative, so to alternate that one, called open hashing, which does not use overflow buckets and is not suitable for database applications. So open overflow buckets are not open for to inserting records, and it is not suitable for database application. So this is closed hashing and open hashing. So what is meant by closed hashing here? The closed hashing are nothing but overflow buckets of given bucket are chained together in a linked list. So the scheme is called as what? Closed hashing. For that, alternative one is what? Open hashing. So in that open hashing, which does not use overflow buckets, so these overflow buckets could not be used, is not suitable for database applications. So creating more number of buckets is creating sufficient buckets or more number of buckets for inserting record. More number of buckets are used for inserting records. So again, the records are to be the search key values. Search key values or search keys are limited for each and every bucket. Because more number of search key values for the same bucket indicates that what? Overflow of the bucket. And deficiencies of static hashing. So in static hashing, the function h maps search key values. So search key value is mapped with the hash function to a fixed set of b of bucket address. So bucket contains addresses. So databases grow or shrink with the time. Based on the time. If initial number of buckets is too small and the file grows, so initially the bucket size is like 1 KB or 100 KB, then the file is added into this bucket. Then the file will be updated. As it updated, the file size will get increasing. So 100 KB belongs to increasing with the 150 KB or else 1000 KB. So as buckets is too small and the file grows, the performance will be degraded. Because of due to too much overflows occurs because of the bucket size is small and the file grows. It will leads to degrade due to too much overflows. If space is allocated for anticipated growth, a significant amount of space will be wasted. Initially. So and buckets will be underfull. That means if space is allocated for anticipated growth, and that means the buckets are created but files are not created, means then buckets are wasted. The space of buckets created will be wasted. So if database shrinks, again space will be wasted. Database also shrinks, then again space will be wasted. For this, one solution is what? Periodic reorganization of the file with a new hash function. So periodic reorganization of the file with new hash function is the solution, and it is an expensive, disrupt normal operation, and it is an expensive process and disrupts normal operations. And better solution is what? Allow the number of buckets to be modified dynamically. That means created buckets are going to be configured or Created buckets are going to be configured or modified dynamically. So we need to modify these buckets are to be dynamically. So dynamic hashing. So dynamic hashing is nothing but what? Dynamic hashing is nothing but what? Modify buckets, modify the records on the buckets as per the changes of the records, as per the changes of the database. It should be modified. So the bucket details, bucket records will be modified. Bucket records will be modified based on the database modification requires. Based on the database modification requires. So whenever the database modification requires, automatically it takes to modify the bucket. It takes to modify the bucket is nothing but inserting or updating the records. It is good for database that grows and shrinks in sizes. It is good for database that grows and shrinks in sizes, and it allows the hash function to be modified dynamically. It allows the hash function. So hash function is to be applied whenever you want to modify dynamically. Hash function is to be applied whenever you want to modify dynamically. So without this hash function, it does not identifies the bucket, so that the bucket could not be modified. Bucket could not be modified as per the records. And here comparisons of ordered indexing and hashing. Comparisons of ordered indexing and hashing. So indexing is also a mechanism to search the values and displays the values based on indexing mechanism. That is nothing but searching mechanism. So it contains what? Search key values and pointers in the different types of architectures. But in hashing is also such type of searching mechanisms to retrieve all the records. But in the hashing mechanism, it contains both search key values as well as hash functions. Search key values as well as hash functions. So at that moment, the indexing mechanism and the hashing mechanisms will work for both indexing search key values. So what are the comparisons we are going to take here? The comparisons. So the cost of periodic reorganization. So to reorganize the file or to reorganize the bucket, it takes a much more amount of the cost. It takes more amount of the cost. And relative frequency of insertion and deletion. Relative frequencies of insertion and deletion. That means there is a small gap between after performing insertions and deletions. There is a small gap between after performing insertions and deletions will take place. And is it desirable to optimize average access time? Is it desirable to optimize average access time at the expenses of worst case access time? Is the expenses of worst case access time. So is it desirable to optimize average access time at the expense of worst case access time? So expected type of queries. Like what? Hashing is generally better at retrieving records having a specified value of the key. So hashing is generally better. It says that what? Retrieving records having a specified value of the key. If range queries are common, ordered indices are to be preferred. And in practice, in PostgreSQL, it supports both the hash indices, but it discourages use due to poor performance. So it supports hash indexes mechanism, but discourages use due to poor performance. So hash functioning mechanism gives a poor performance comparing with the indexing mechanism. And Oracle supports static hash organization. But not hash indices. And SQL Server supports only B plus trees indexing mechanisms. So SQL Server indexing supports only B plus tree indexing mechanism. So Oracle supports hash organization, Postgres supports hash indexes, but those two are not favor about performance and not favor about indexing mechanism. but organization wise it's okay. Organization wise it is displays, it accepted, but for the indexing mechanism it does not accept it. So these are the comparisons while coming to the both indexing and the hashing mechanisms. So this is all about to hashing and the types of hashing. So dynamic hashing and static hashing. So dynamic hashing is nothing but what, whenever you want to modify the data in the buckets based on the size and based on the files are added. So that is nothing but dynamic hashing. But in the static hashing, there may not be change. There may not be change or modified on the buckets records, so that it will take as a static hashing. So once again we revise the topics which were discussed in this session. So here the first one is what, hashing. So what is meant by hashing mechanism and static types of hashing, static hashing and dynamic hashing. So here hashing is nothing but what, hashing is an indexing mechanism that uses search keys to retrieve the records, based on hash function, that hash function uses search keys to display the values. So here in the hashing mechanisms we are using a bucket and a hash file organization. We are using a bucket as well as hash file organization. So bucket is nothing but what, it is a unit of storage containing records. But hash file organization is nothing but what, obtain the bucket of record directly from its search key values. So how you are going to place the search key values in the buckets and where you are going to place the search key values using this hash function. So there are two types of hashings. One is what, static hashing, and the second one is what, dynamic hashing. One is what, static hashing, and the second one is what, dynamic hashing. So static hashing is never changes. About to modification, but dynamic hashing will changes as per the database modifications. So here examples of file organization. There are different types of buckets are there, and for all these buckets and for all these brackets there are so many data are also inserted. So for each and every bucket having one record, for this bucket 2 records, for this bucket 3 records, for this bucket 2 records, for this bucket 5 records, and for this bucket 3 records. But to retrieve all that, all the records, you have to use the search key values. So on basis of search keys, as a the department ID or instructor ID or else department name, as per these search key values, the search key values only display, records will be displayed on the search keys. Based on the search keys the values will be displayed, and at that moment sometimes bucket will not be filled with all records, and the bucket will have more than the records which contains bucket size, more than one records which contains the bucket size. So at that moment the bucket gets overflow and underflow. So here the hash functions are two types. One is uniform and the second one is random. Function and the second one is random function. So uniform function is nothing but what, each bucket is assigned the same number of search key values. But in the hash function is random, each bucket will have the same number of records. Where in the uniform each bucket is assigned with the same number of search key values, but in the random each bucket will have the same number of records assigned to irrespective of the actual distribution of search key values. So that is the two types of hash functions, uniform and random functions. And bucket overflow. So bucket overflow will get whenever the Buckets are not organized. Buckets are not sufficient for the file organization. Buckets are not sufficient for file organization. At that moment, it gets bucket overflow, and it is having multiple records have the same search key values, and the chosen hash function produces non-uniform distributions. So that is the handling of overflow bucket overflow. So how the bucket will works here, and the closed hashing and the open hashing. So closed hashing is nothing but what? The overflow buckets of a given bucket are chained together in as a linked list form. As a linked list form. So that is nothing but what? Closed hashing. But an alternative method is called open hashing, which does not use overflow buckets, but it is not also suitable for database applications. It is also not suitable for database applications. So closed hashing and open hashing. Deficiencies of static hashing. So deficiencies. What are the deficiencies? If initially the number of buckets is too small and the file grows, the performance will degrade because of the too much overflows. Because of the too much overflows. And if space is allocated for anticipated graph, then significant amount number of spaces will be wasted. So if the correct records are not inserted into the bucket, then the space of bucket will be wasted. If more number of records are inserted into the bucket, then bucket will get overflow. Bucket will get overflow. For that, the better solution is what? Allow the number of buckets to be modified dynamically. Allow the number of buckets to be modified dynamically. So as per these solutions, you may change the values based on the database requirements. So by following this dynamic hashing, it is a good for database that grows and shrinks in sizes. And it also allows the hash function to be modified dynamically. So hash function is also to be modified dynamically. And here the some comparisons, indexes and hashing. So indexes are used by SQL server with the help of B plus trees. But in the practicing hashing techniques, PostgreSQL supports hash indexes, and Oracle support hash file organizations. And access wise, overflow wise, it shows that indexing mechanism also important. Indexing mechanism is improves more performance than the hashing organization, hash file organization or hashing process. So this is all about hashing under types of hashing. So hashing is nothing but what? The process of searching the values or retrieving the values based on the search keys using hash functions. And there are two types of hashings are there: static hashing and dynamic hashing. Dynamic hashing will allows you to modify the data or records buckets dynamically. But in the static hashing, you are not allowed to modify dynamically. So this is all about hashing and types of hashing. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.